Today we're looking at LeetCode Problem 206, Reverse Linked List. Given the head of a singly linked list, reverse the list and return the reverse list. Here's an example where the nodes are equal to 1, 2, 3, 4 and 5, and then we reverse that and get 5, 4, 3, 2 and 1. The approach that we're going to be taking is called the iterative reversal of linked list. It has a time complexity of O of n and a space complexity of O of 1, and it's the optimal approach to this problem. Now let's walk through an example where we've given a linked list with nodes 1, 2, 3, 4 and 5. Step 1. Create a previous and current pointer with values null and head respectively. So here's our previous, and here's our current, which is pointing at the 1 node. Step 2. Loop over each node while current is not null, applying the following logic. Next is equal to current.next, current.next is equal to previous, previous is equal to current, and current equals next. So next is equal to current.next, which is the 2 node. Current.next is equal to previous, so the 1 node is now pointing at null. Previous is equal to current, so let's move that over to the current node, which is 1. And then current is equal to next, which is the 2 node. Then we go back up again, and we say next is equal to current.next, so we'll move next over to the 3 node. Then current.next is equal to the previous, so the 2 node is now pointing at the 1 node. Then we'll move the previous so that it's equal to the current, so previous is now pointing at the 2 node. And current is equal to next, so we'll move the current to then point at the 3 node. Then back to the top where next is equal to current.next. So next is now pointing at the 4 node. Current.next is pointing at the previous node, so the 3 is now pointing at the 2. Previous is equal to current, so we move the previous to point at the 3 node. And then current is equal to next. So the current is now pointing at the node with a value of 4. And next is equal to current.next, which is 5. Current.next is equal to the previous, so the 4 node now points to the 3 node. Previous is equal to current, so previous is now pointing at the 4 node. And then we move the current to the next, which is the 5 node. Then next is equal to current.next, which we can see is null. Current.next is equal to previous, so the 5 node now points at the 4 node. Previous is equal to current, so let's have the previous pointing at the 5 node. And then we set current equal to next. And we can see that next is null. And while current doesn't equal null, we're in the loop. So we need to break out of the while loop. And then finally, step 3, return previous. And that's it, the linked list has now been reversed. Thank you very much for watching, it's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Let's look at LeetCode Problem 206, Reverse Linked List in Java. So given the head of a singly linked list, reverse the list and return the reverse list. Example 1. We're given a linked list with nodes 1, 2, 3, 4 and 5. That gets reversed to 5, 4, 3, 2 and 1. Example 2, we're given a linked list where we've got nodes 1 and 2. And we can see that that gets converted to 2 and then 1. And then finally, we're given an empty linked list and we return an empty linked list because there's nothing to reverse. So there are sort of three or four edge cases that I think are important to discuss. The first one would be where we're given an empty linked list. So our solution's going to have to handle that. So where head equals null, we just return null because obviously there's no linked list to reverse. Secondly would be we're given a single node linked list. Again, the head is going to equal the node. So basically we just want to return the node that we were given because again there's nothing to reverse. Another test to mention is example 2, where we're given 2 nodes, and we would then want to just make sure that our solution works when there is only 2 nodes. And a final edge case that I can think of would be where we have got the same value in every node. So this would be something like 1, 1, 1, 1, and 1, and just making sure that in that scenario our reversal of the linked list still works and that the pointer is pointing to the what was prior node. Cool, so let's get into it. The first thing that we're going to do is we're going to declare 2 variables. So they're going to be list nodes. We're going to have one for previous, which we'll set equal to null, and then we'll have another which will be called current, and that will point at the head. And then we want to loop over the linked list while current doesn't equal null. And we declare one more variable, which is also a list node, and we'll call that next. And we'll set that equal to current.next. Then we want to set current.next equal to the previous. We want to set current, what do we want to set? We want to set current equal to, sorry, no we don't. We want to set previous equal to current. We then want to set current equal to next. Cool, so let's look at this then. So we initially set the current equal to head, which is the start of the linked list, and that's the current node that we're looking at. So in a scenario where we're given an empty linked list and that's null, then it's straight just going to skip this entire while loop. And in that scenario we would then want to return previous. Obviously previous is null, as current would also be null. Then we say next is equal to the current node that we're looking at, the next one. We then set current.next equal to the previous node. So we've switched the direction of the link in the list. We then update the previous to where current currently is, and then we update the current to the next node in the linked list. Once we've come to the end of the linked list, it's the value for the current is going to be null, and we'll break the linked list, and basically we just then want to return previous. So we'll run that, see if it runs. It does, brilliant, and let's submit it and see if it passes the edge cases. It does, and it says that it beats 100% in terms of runtime and 68.79% in terms of memory. So the runtime complexity of this is O of n, and the space complexity is O of 1 constant, and that is the optimal solution to this problem. Thank you very much for watching. I hope that you liked the video. If you could please click like and click subscribe, that'll hugely help the channel out. If you've got anything that you'd like me to produce in the future, or any feedback that you've got for me, please leave it in the comments below and I will get right back to you. Thank you very much for watching, and good luck with your coding.
Bye.